This video will review how to calculate formal charges. First of all, what is a formal charge? A formal charge is a bookkeeping device and does not necessarily reflect the actual charge on an atom. It can be calculated for any atom in a molecule or ion. It compares the number of valence electrons that the atom started out with to the number that it is assigned in the structure, assuming that any bonding electrons are shared equally between two atoms. If an atom has a formal charge of 0, that means it is assigned the same number of electrons that it started out with. If it has a negative charge, it has extra electrons, and if it has a positive formal charge, it has fewer electrons than it began with. To calculate formal charge, we generally start with a structure. Let's use ammonium, NH4+, as an example. First, we'll draw the Lewis structure. The total number of valence electrons in our structure should be 5 from nitrogen, plus 4, 1 from each hydrogen, minus 1 because of the positive charge, giving us 8 total. We'll put the nitrogen in the middle and arrange the hydrogens around the outside. When we draw in all of our single bonds, we've used up all 8 electrons, so this is our overall structure. In general chemistry, we might use a bracket like this to show that this species has an overall charge. There's a formula for formal charge that you've probably seen before. Formal charge is equal to the number of valence electrons that the atom started out with, minus the number of lone pair electrons that the atom has in the molecule, minus 1/2 the number of bonding electrons in the final structure. This formula can be a bit confusing, so we'll also go through a trick that we can use instead. However, let's start by using the formula to calculate the formal charge for a hydrogen on our structure. The hydrogen atom on its own has 1 electron. In the structure, it has no lone pair electrons and 2 bonding electrons. Bonding electrons count for any atom involved in the bond. So in this case, they count for both hydrogen and for nitrogen. So if we do our formal charge calculation, we'll have 1 valence electron minus 0 lone pair electrons minus 1/2 times 2 bonding electrons to end up with a formal charge of 0. All of the hydrogens in the structure will have a formal charge of 0. Next, let's look at nitrogen. Nitrogen, as we can tell from its position on the periodic table, has 5 valence electrons to start out with. In the structure, it has 0 lone pairs and 8 bonding electrons. So we'll have 5 minus 0 minus 1/2 times 8, or 5 minus 4 to equal 1, giving us a formal charge of +1 on nitrogen. In organic chemistry, if we are working with a molecular ion as we are here, we generally draw the structure showing the specific formal charge on an atom instead of showing the charge on the overall structure. So we would show NH4+ like this. This will help us as we keep track of the movement of electrons later on. Here's one of the shortcuts that I use when calculating the formal charge. I still start with the original number of valence electrons for the atom, but then I draw a circle around the atom and count how many electrons are inside the circle. Half a bond counts as 1 electron. So if we use this trick for nitrogen and ammonia, we can see that there are 4 electrons that we would consider to belong to nitrogen in this structure. 5 minus 4 still gives us the same +1 formal charge. Here are some reminders for formal charges. As we discussed, formal charges can be calculated for each atom in a molecule or ion. Formal charges can affect how we draw Lewis structures. The best Lewis structure will generally minimize formal charges. If a negative formal charge is present, it should be on the most electronegative atom. Finally, the sum of all formal charges must be equal to the total charge on the molecule. Let's do another example where lone pairs are involved. Try drawing the Lewis structure for ozone, O3, and calculating the formal charge on each oxygen atom. I would encourage you to pause the video here and try this on your own, then check your work as I go through the example. For ozone, we start off with 6 valence electrons from each oxygen, or 18 total electrons. We'll arrange these oxygens in a line and fill the octet of each outer oxygen. You might wonder why we don't put the oxygens into a ring. Such a compound would be too unstable to form. How would you know that ahead of time? You might not. However, if you're asked to draw a Lewis structure, you can usually assume that the compound will be linear or branched, but not cyclic, unless you're told otherwise. Now, we've used up 16 electrons so far. We have 2 left that we can place on the central oxygen. This oxygen does not yet have an octet, but we've used up all of our electrons, so we'll have to share a pair and make a double bond between 2 of the oxygens. It doesn't matter which 2 we make the double bond between. We'll see why when we talk about resonance. Now, all oxygens have an octet. As we mentioned before, each oxygen started out with 6 valence electrons, so we'll use that to calculate our formal charges. On the oxygen on the left, we start out with 6 minus 4 lone pair electrons minus 1/2 times 4 bonding electrons. That gives us a formal charge of 0. On the next oxygen, let's try the circle method. We had 6 to start, minus 1, 2, 3, 4, 5 in the circle. So we have a charge of +1 on this oxygen. On the last oxygen, we have 6 lone pair electrons and 1 electron from the bond. Subtract these 7 from the 6 that we started with, and we get a -1 charge on this oxygen. Our +1 charge in the middle oxygen, added to the -1 charge on the end oxygen, gives us the total charge of 0, which is as it should be. In organic chemistry, we might draw ozone like this to show the formal charges. In organic chemistry, we see the same formal charges over and over again, and this can be seen on the common bonding situations handout on Canvas. I'll also summarize some of these formal charges that we see here. Carbon with 4 bonds, nitrogen with 3 bonds, oxygen with 2 bonds, or a halogen with 1 bond always has a formal charge of 0. Carbon with 3 bonds and no lone pair, nitrogen with 4 bonds, oxygen with 3 bonds, or a halogen with 2 bonds have a formal charge of +1. Carbon with 3 bonds and a lone pair, nitrogen with 2 bonds, oxygen with 1 bond, and a halogen with no bonds all have a -1 formal charge. We will see all of these during this semester or next semester. So for now you should be able to calculate the formal charge, but you should also get used to recognizing the formal charges on these common species. Drawing in the formal charges can help us understand the reactivity of compounds, as we will see soon.